We have mentioned that a lot of traffic is going on here. There are hello packets being sent from one router to another. There are LSAs, LSRs, all of this traffic constantly going. In fact, every 10 seconds these hello packets are flying all over the place. Well, that's a lot of packets. How can we cut that down? And the way that we do it reminds us a little bit of Spanning Tree Protocol. As a matter of fact, the same people who developed Spanning Tree Protocol also developed this system. So here's what it does. It elects a DR or designated router, a BDR or backup designated router, and then all the other routers are DR others or druthers. Now in this particular diagram you have all point-to-point links. And so that election process will not take place on this. However, if we had a network that looked a little bit like one I'm going to bring over here in a second, like this, so that we have multi-access routers, then the election process would certainly take place. However, it's not going to happen here. But let's look at this and pretend here for a moment that we are going to choose which one would become the designated router and backup designated router if they existed. The first thing that happens is it looks for the router ID. The router ID. Now, the router ID by default is 1 on every router. However, that can be changed to any 32-bit number, and you can change it yourself to any 32-bit number. Now, bear in mind that an IP address is a 32-bit number, and it usually looks like an IP address, but it doesn't have to be. It can be above 255 in an octet, but you can change the ID directly. If they're all the same ID, and by default they are, they're all 1 by default, the next thing it does is it looks for a loopback address. And if there's a loopback address, it uses the highest IP address on the loopback addresses to find the which one will be the designated router. If that fails, if there's no loopback addresses, the next thing it does is it looks at the addresses themselves on these routers and says which one has the highest. Well, in this case, this one has the highest. It has a 192.168.6.2. The backup designated router would be 192.168.6.1. That would be this one. And then this one, 5.1, would just be a druther. Now again, remember that because these are point-to-point links, we won't actually see this on this particular network. It would have to be a multi-access network for that to happen. So this is called a point-to-point network here. So that's what it does. And in your labs, you will change some of the things that could affect that. You'll change the router IDs, and you'll put loopback addresses on these things and so on. But of course, you won't actually see those results. Let's take a look at one of them. Show IP OSPF neighbor. And you'll see that this router that I just chose here has 2 neighbors. The neighbor ID of 6.1, that would be this router, and the neighbor ID of 5.1, that would be this router, and they have formed full neighborships. But you notice this little dash here? That's where we would have information about whether this is the designated router or the backup designated router. And if we had to choose, this one would be designated, that would be backup. Well, actually, the one we're on would be designated. This one would be backup. This would be a druther. But that's how this process works. And so just be aware of it. And remember, too, that you can also change the router ID. You can change the loopback addresses. So you have power over who's going to be the DR and the backup DR.